All right, we are back with the repaired power supply board soldered back in. Still don't have the transistors in here in the middle, so we're not going to be driving anything. Nothing's going to come on, or really shouldn't. Fan might come on because it's probably 12 volt right here. Probably turned on by something right, one of these transistors maybe. But what we're going to be worried about is see if I can do this. Is looking up there at the scope, and I'll try to zoom into it. We're just wanting to look. It happens to be all the square pads. Let's see if I can. You look a little dirty. Hang on. I gotta get my bald head in here for a second. Is that missing a pad, or is that just dirt? I thought I cleaned that all up real well. Yeah, it's missing the top of its pad on that one, which I don't think matters. I think that's the one that connects in from the bottom. Yeah, nothing else connected on the top. So that's what happens when damage happens. But if I zoom in, maybe I can pull this over. Let's get zoomed deep in what we're wanting to look at. There we go. Let's see if I can get a little pointer. Happens to be the bases are all these square pads. Oh, one off. Not there, not there. Here we go. So the square pad, so we know where the base is. And then that's the base on the transistor. So there we go. Okay, so we need the oscilloscope, and I have power hooked up to it. You'll see the power go up a little bit. Yep, right up there in the corner, you can see the power supply, and the fan did turn on. But we're not driving anything, so we should see a nice square wave on that pad. We do. And so let me show you what a good one looks like here. Let's make the scope big. There's that, and I'm just going to skip to each pad and make sure I got a good square wave. That's what's coming. That's what we made work. Once we got that power issue sorted out on the power supply driver board, there's those four. So now I'm going to go back here to the working one. So I did all those, and I'm going to go over here and very carefully look at each one and make sure that I have drive on every transistor all the same. I don't want to have a bad resistor that leads out from this driver board, or any of the pull down type stuff, or anything else that might be connected to it. Any diodes or clamps or anything, blah 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 blah. Who knows? You know, let's not get technical. We're just looking to make sure that every single one, this is the way you don't have to be an expert on what all's going on if you just check. Sometimes you don't have to be an expert about what you're doing, as long as you test what you do know and make sure that's all good. And every one of those tested just fine. So I'm going to let off the power there and kill that up here. And so now we go to my little drawing, and I know what my base emitters and collectors are, and I actually labeled what they should be there. And so I have to sort out. I threw everything back in the bag here. I've still got a few resistors to install, and then we're using BD 139s and BD 140s. Is what I'm going to use to drive all these FETs. They'll work just fine. There is one of these can be replaced. If you watched the earlier video, there's another part number my buddy Sean's been using. I think it looks exactly like it, like this style, but I think it's actually supposed to be a little bit stronger as far as survivability if something goes wrong in the power supply. But normally the BD139s and 140s work just fine, and I have a ton of them that I need to go through, so I most likely haven't ordered the new number yet. So I'll get a few more. I've got, must have lots of gate resistors. I stuck everything back in the bag when I cleaned up to do the work and stuff in there. So I will have to peek at each one of these and see which one it is. And so give me a minute to sort that, and then I got to see what we need. I need to suck these holes out. So what I'm gonna do is I'll go off camera. I'll get these all sorted. I'll probably drop these resistors in. I've got 1, 2, 3, 4 that are missing over here. And I believe I've checked everything else. It's been a few days since I've been to this, so I got to remember. So I think that's why I only got 4 in the bag here. Get all these laid out. Like I said, if you have watched that PPI video, you'll know exactly how we determined which transistor goes where. I'll go on ahead and get it, and we'll label this little drawing right here, so that just so that everybody else has it, and everybody else might be able to understand it. Or if you get an old scrap Korean designed board and you're going to play with it and you're trying to learn, you can verify some of these things off this. I'm not going to re-explain all of it because it's all perfect in that video, but I do want to put this layout for us to be able, for somebody to be able to look back on and review. I've got one here that appears to, oh, there's its markings. Okay, so give me a minute to clean up those holes, and I'll go ahead and put those resistors in. I'll probably put almost all these in once I get them sorted, but I'll go over in a video shoot putting the last couple in and marking these, and that way you don't have to watch me do boring solder work. You know, I like try to show some of that, but you can watch several of my other videos to see that. Now, one thing we will say is once I get this in, it's going to start running these FETs over here on this top side. We don't have any in over here, so we'll have to see. There's individual wire strands on this one and this one. How that affects our voltages being made. We may have to add the FETs over here, so we may have to put in at least 2 or all 4. These front 4 power supplies do not have the individual ones, so they're not making the auxiliary voltages. So we may have to do that to get all the correct voltages. I'm on purpose going to leave the driver board in, and I'm not taking it out yet on purpose, because I want to get the power supply up and running. We want to check for the correct voltages, see if anything is going squirrely there, and going squirrely there maybe because of the driver board, and then we'll check the low side drive, and we can kind of look at some stuff. My hope is that maybe there's something, if there is something here, that I'll be able to show it to you before it's repaired and what looks bad, and that we can then take the driver board out. We can check some other stuff. So if one of the voltages is way low or something, and we take the driver board out and then it comes back perfect, we know we got some kind of short on the driver board or something. And so show you a few things to look for, that once you have the power supply running with all the output FETs out, before you take the driver board out to rebuild it, because like I said, those chips have to be replaced. If there's been a fault in any of the outputs, you just got to replace those chips. They do the job, but they're delicate. But things you can look for before you pull it, because you're not going to blow nothing. You shouldn't blow anything with no outputs. If everything's hunky-dory and it actually looks like it's driving everything just fine, then the only thing we have to do when we take this out is just replace those 2 chips as a precaution, so that we make sure that, you know, they didn't take a tiny bit of damage, which is what they normally do, and what they'll end up blowing your new FETs. But you just won't be able to see it. But if everything works perfect and we see all that stuff, then it's really sweet, because then you just pull this board, swap those 2 FETs out, stick it right back in, and you can put in your test FETs to start going, and it's a faster repair that way. And you don't have any other problems on anything else on that chip, or the 5-volt rails or the 12-volt rails and stuff like that. So let me get those holes cleaned up, get most of these in. I'll save it out. We'll label this, and I'll make it, I'll get a good zoom in of it so that everybody, and I'll explain it a little bit to make sure we have a good recording of how that works, because this, if this didn't have an extra set, if it was only 4, then there's a good chance it could be this way. Might help you out, or at least help you figure it out on your own with this video and that other video. And you can play around with an old beater amp that you got there, and maybe do a little learning. That's always my hope. All right, I'll see you back in a minute. Okay, I want to bring you back in real quick. We've just barely got anything done here. I'm going to use the voltmeter. Let's zoom in. Just because there's a little learning to be done. And as you can see right here, we have put the transistors in this middle spot. Let me zoom back out. So we've got them here only. You can see over here I've still got batches to do for here and here. So all this is powering, all this is switching. This little group switches for that one, that little group for that one. So we are, the only one we have FETs in that we're switching is going to be for this pair. No, Ellie. Sorry, the dog is playing with her bottle and was making a catastrophe. So anyway, so I'll make sure I'll say that again. No puppy dog interruption. So we only have this 4 and this 4. These 4 would drive this bank of 4 on this whole transformer. These 4 over here, and this is the only side we have drivers in and FETs. So that's the only section that's going to make rail voltage. Now we had said these 4 up front. Pardon my dog. She is going after that bottle, chewing on it. Are not going to make any of our secondary voltages. It's going to be this one with the single wires and this one with the single wires. So I'm going to go ahead and power it up, and I'm going to watch the lights down here. I can't get a wide enough angle shot. I don't want to move this around too much and everything with the board on it and stuff, and it not being all properly supported. But I'm going to hit it, and I seen a flicker from the red LED that said protect, but it went away. I heard the relays kick in, but I don't see the good voltage or the good light come on. So we're going to look, and here we got the multimeter set at 200 volts. Oops, sorry. So we just built up some rail voltage. We're pulling an amp up there, you can see. We just built up rail voltage to 100 volts there, and negative 100 volts, sorry. And then there we're a little over 100 volts here. So we have got rail voltage being built there because of one of the transformers, but because we're not seeing the light, I'm just wondering. These are the, pardon my bald head, these are the 15s. And I'm not getting any voltage on the 15s, but I'll bet I'm getting them over here on the 12s. Yep, because these are going to be referenced to the rail voltage. So we're still missing it because we don't have that side. And I wanted to just do that real quick because I thought I might need to put those in. I did go ahead and get the resistors in up here also. So I'm going to get 4 more FETs and add them in over here. And then do set up a couple other shots, and I'll try to get this moved as I put in some of these and we talk about this. But I just wanted to show that paying attention that I had 2 different transformers that had the single winds to produce my secondary voltages was important, because if I thought I could power this all up off this one, I would be sorely mistaken. I bet it's this one that's going to run these plus or minus 15, and that'll probably give me my lights. So Let me do a little more, just install 4 FETs here, and then we'll probably bring you back. I may go ahead and install some of these and leave a group. What we can do right now is go ahead and carefully explain. So just like the other video we had, let me zoom in, bring this down a little. In the other video, I probed this and we'd checked for positive and negative, and we'd wrote the positives and negatives on these, and then we'd noted which way the board showed the transistor was in and stuff. So what we are looking for is the negatives are here in the middle on the collector. See how we've labeled that? They're going to be base collector emitter or emitter collector base, depending on the way the transistor is facing. And so this flat, this means that flat, normally that will be the flat of a regular transistor, and that's where they put all the markings. On these, since they're square and rectangular and everything, it just still means we're at the side of the markings. So we got BD139s, and they're NPNs, and BD140s, they're PNPs. And when I make my drawers for my electronics, I always put in information like this. So my drawer for BD140s also tells me that they're PNP, and it's ECB facing at me. So this is the 140, so it'll be emitter, collector, base. And that way I know just at a glance, because I'm not an expert. I don't do this every day for a living, so just having those little reminders helps me out. So we're going to have our negatives on the collectors. And positives on the collectors also. And so we need the collector with the negative is going to have the PNP. So negative collector, trying to make sure I write all this out and do it right, and then positive collector, the puppy dog needs out, is going to be the BD140s. So I'm going to take BD140s and I'm going to install with a writing on this. I've already done this one, so this next bank I'm going to put that one like that, and I'm going to put a 139 just like that. So they'll end up facing me with black writing. But on this side, it'll be a 140 facing that direction with the writing, and this way with the writing. And so that's how I'm going to put them in. And so I'll finish putting all those in, and we'll get 4 FETs installed, and I'll bring you right back. And I'll let the pup out too. Alrighty. So we're back. I've got a toothbrush, a plastic toothbrush underneath here to help keep the board level, because I've got the end on, which I've got down in this camera that you can see in the upper thing, so that you can see the power and protect light right there, hopefully. Up in the corner up here we got the voltage for the power supply turned on. And so what I've done is, let's see if we can come up with a suitable pointer here. There we go. I went ahead and installed all the FETs and all the drivers so we could get full voltage everywhere and we could give it a check out. So let's just go ahead and do that. Let's hit it. The fan kicks on, pulls a whole lot of current, tries to come on. It's going out of protect, but if you look up there, right here, see it's flashing back and forth. So let's take our multimeter, put it on 20 volts here. We're going to hold that, and something's running us into protect. I happen to know that pin 11, oh, you guys can't see that. Hang on, let me just turn this where you can. Pin 11 is the shutdown pin coming in here. Remember we talked about all the pins on this thing. You kind of see it maybe is doing something. Let's see if we can grab the scope here. Make that a little better. So let's see that on the scope, how it keeps pulsing, keeps pulsing, keeps pulsing. Something kind of goes in frequency into that. That pin's getting raised up. Well, I happen to know, if we go here, that some of the protection circuit goes into that number 11 pin. I've traced it all out, and it runs back up over here to the speaker output, to part of the DC offset voltage protection over here on the speaker outputs. And so it runs over to these little components over here, and there's a little transistor that'll turn that on. And when I got over here, I'm going to turn everything off so I can unhook stuff. Give you a little, oh, that's not what I wanted to do. There we go. Don't bang your mouse when you're recording. Take that apart, pull these power wires off. See if I can bring this over. Now that that end cap's off there, I don't need that. Let's see if we can zoom in a little bit more over. Anyway, there's something missing there. There's a component with pads, but there ain't no component. And that's supposed to be a big resistor, and that big resistor for this DC offset protection provides a path to ground. So at some point in this mess of an amp, that has been lost, broken, or something. So I ordered up a new one, and we need to get that soldered in. And then we'll see if it won't protect, because right now that protect circuit has no reference to ground. So we're going to fire up the old soldering iron, get a little water on the old sponge. Carefully flip this over with that in place. It just barely sticks out there, so it's probably going to want to fall out. I'm going to see if I can get my pliers here. Bend those legs over just a little. They're not very long, but that's enough to hold it in place. Get the soldering iron fired up. That's one of the failures of my poor little multimeter. It doesn't do a good job. This is not a high-end multimeter by any stretch of the imagination. That's on my list of things I'd like to get, is a much better multimeter. But you know, it was just barely flickering, showing us 1 volt, where the oscilloscope was showing us it was actually switching all the way up to 12 volt. My meter just wasn't fast enough to catch it because it was pulsing so quick. Might have caught it better in AC, but normally you're checking stuff DC because it's a DC amplifier. The amplifier runs off 12 volt DC. And on the power supply side, everything should be 12 volt DC. You don't get your high voltage until you get your power supply operating. Okay, let's see if we get this flipped back over real careful. Let's zoom back out for you. Let's move this down a bit so we got room. We're going to carefully add the little brace so that we can put less strain on the pins of the output card here. Get that slid into place. Move the multimeter out of the way of the camera. And okay, we've got the light back. I'm going to bring our power wires back in. Turn the power supply on. That's all good and well now. Got my scope to keep from freaking out. And now that we have that, hopefully that'll provide the ground for that to reference. And let's see if we are still pulsing protect. So let's go ahead and check that. Yep, you can see it on the multimeter. It's jumping up. I've got that on the, is that 2 or 1 volt? That's 1 volt, so it's jumping 1, 2, 3. It's jumping at least up to 5 volts each time. So now we're going to have to check and see why. So there shouldn't be any DC on the speakers. There's not. So something else is jumping that little sucker to turn on. I know that, what is it, Q226, is that what that is? No, that's Q301. Well, give me a minute. I'm going to let the power go off here. We'll double check the rail voltages. I'll turn this, make sure that's bled down before I do anything. So I can go to center tap here. Make sure those are still dropping. Now you can't see that. Oh, we got glare. Oh, I got new shop lamps, by the way. There we go. It's a little glareless. So we're still dropping. So I'm going to wait for this power to drop. I'll come back whenever it's done. But I replaced all my fluorescent lights with some LEDs. So I got great light in my shop. It may make some additional glare, but I'm going to learn to live with it, and I'll figure something else out later for recording because I got other lights that might help with that. But it's been fantastic in my garage to actually have some light to work with. So anyway, like I said, we'll get this voltage bled down, and I'll have this pulled back out of the way. I'm going to remove the end cap and stuff here. Give me just a second. Alright, so I've flipped the board over. I've got power hooked up and the power supply is on. And we're ready to do some checking. So this board, since it's flipped over, this is pin 11 back here. And then we could trace it. It goes through a diode here. Comes over here to these. Oh, hang on, let me zoom in here. Let's see if I can move this down just a touch. Get that centered up on what we're doing here. Maybe I can get a little more of a zoom. Okay. Boy, I'm terrible at this. There we go. That's pretty. All right, so on my meter, I'll stick my meter. I'll have to stick something kind of underneath it here to keep that glare off. That works. So we're going to be powering this up. So you need to keep your hands off the board if you was doing this, because we're pulsing the power supply and it's building some rail voltage. You don't want to rest your hand on that board here where these rectifiers are down here and the rails or all these caps are, because that's, you know, down through this area, because that's all going to have high voltage on it. Remember, I waited for the power to go out, flip this, but I got to be careful. So I'm going to actually probably do a little of this number, or maybe use my pinky to get a good hold as we go across here and do these. And then my negative's going to go on the negative terminal. So let's get zoomed back in. Always be careful. You know, everything you do is at your own risk. Your mom's not here to to tell you that that's dangerous. I'm telling you, if you don't listen, not my fault. So we're going to go on ahead and power this up. We should see a little pulse on here when I make sure I get on there good where I don't. So we know that when that multimeter is jumping a little like that, it was actually jumping up to about 2.5 volts. So if I move over, this is the end of the diode. And then I'm going to move to the other side of the diode. And uh-oh, we don't get anything. So the protection pulse is not actually coming from that circuit. It's not coming from there, which makes sense because we don't have any outputs in this amp, so it can't be producing anything out here to the speaker terminals. So that pulse is being generated on that board. And remember, this power supply board here, I'm going to carefully unhook, make sure I get my power turned off. Carefully unhook this and then carefully flip it back over. Remember, this power supply board had a bunch of damage on it that we fixed back up, and we got it to produce square waves and stuff, and that's all good. But there might be some more damage that I didn't see that's causing it to do that. And so what I'm going to have to do is I'm going to have to get my big fat head in here and maybe do a little sketching to make sure I know which way the TL393, I think it is, 339 or something like that, or 29 or 293. Sorry, bleh. It could be a 30 or something. I'm trying to look here. Let me get my fat head in here. Sorry. Oh, I thought it was a bigger one. It's just a little L393. So it's this small chip here. It's going to have two different sets of inputs and give out an output. I could have swore there was a bigger setup on that, but maybe I'm wrong. Most I'm used to Rockford amps. That's why I was thinking the bigger one that has a quad, and this is just a dual. So I'm gonna have to double check and figure that out. But we're definitely getting a pulse back there on pin 11, and pin 11 should actually be an input to that little bitty chip that's there. And so we may have to pull this board back up and see. We may have had other damage there. Something else is going on. But we're going to do that in the next video. I'm going to wrap this up. I've got lots and lots of footage. I'll have to edit it real good. Wanted to make one quick shout out thing. I did finally bust 1,000 subscribers. Thank you everybody that subscribed, and I hope whatever part of the electronics you enjoy of this, or if you just like to see an amps get fixed, or you like to see a big goober shock himself on high voltage rails, that's cool too. I get it. But I will be doing 1,000 subscriber special. I just have been super busy with work and home stuff, and just have not had time to sit down to the bench. And so I will do my best to get that done and going. I've got 100 things I'm wanting to get done, and I just don't know if I'll have time to get everything done the way I want it to, but I'll do my best and I'll try. That's all anybody can do. So we will see you next time. Thanks for watching. Like, comment, and subscribe, all that crazy stuff. And then we'll get to seeing why this board is producing its own pulse, not the protection circuit over here for the speakers. And once we get that, that should allow it to power up. We should get full rail voltage then. Once we have full rail voltage, I'm going to carefully try not to go. I did notice when I was flipping stuff around, we have not removed the driver board yet. We're going to end up having to remove that to at least replace the two main chips, but we also have to check a bunch of stuff. But when I went down here to look, because I thought, you know, what is there any other protection circuit stuff for this? I did notice, let me get something that's somewhat safe to point. it's already missing an inductor right here. You can just barely. If you look, there should be two of those little green inductors right there. If you see my finger, and it's missing one. So those inductors and those big green resistors are things you have to check because they provide the voltages and feedback and stuff to this board. So we're going to have to get to that. So I may also go ahead and pull this board with my fart gun, you know, the solder sucker, get this out of the way so that I can get in here and we can probe those, and I can show you measuring those because we need to start addressing that too. But I really was wanting to leave this in to show, maybe show that once these have been damaged, there's a possibility it could still show good drive. However, this style chip you never trust at all to have survived correctly to be able to redrive FETs again. So, but you know, they can give you false hope that, oh, it's okay. It's not. You have to replace those every time. But we were just going to go ahead and do it because I was hoping maybe we'd get some wonky readings and I could show you how tore up those things could even still try to run. Maybe even what a dead signal looks like, all that other stuff. But we may have to skip that since we're already missing some parts down here. Like I said, this amp was a mess. It was I bought it from a friend who had taken it in on trade, and he got so busy fixing amps that he was like, he's slowly been selling me a few, and it's really awesome of him because he just doesn't have time to get to them. And so it allows me to do some of these amps that I might not be able to get around. Sundown's really hard to come by in my area. There's not an actual Sundown dealer close, so it's really, really hard to, or it's really, really difficult to pick up amps. If there's not a ton of them sold in your area, then that means there's even fewer, small, tiny percentage that ever are dead. And so it's just hard to get it. So, all right, I'll let you go. Sorry, I'm babbling. All right, thanks a bunch, guys. See you in the next one.